Good morning. Today we will learn about another important topic in engineering mechanics, that is curvilinear translation. So here also there are two different type of problems involved, that is kinematic problem and a kinetic problem. So far we have been dealing with particles moving in a straight line and the motion was termed as rectilinear translation. So in the case of curvilinear motion, the particle will be moving along a curved path and the motion will be termed as curvilinear motion. An example for curvilinear motion is a projectile motion. Now, the path of a particle moving along a curvilinear motion can be described with the help of three different coordinate systems. First one is the rectangular or Cartesian coordinate system. The second one is normal or tangential coordinate system, and the third one is with the help of polar coordinate system. Now let us take the first coordinate system, that is rectangular or Cartesian coordinate system. So here we will consider a curved path AB and let P be the particle which is moving along this curved path. Now let X and Y are the reference axis, and we can see that the particle P is at a distance of r from the origin. Now, in order to locate the point P, we need two coordinates, that is the coordinate along the x direction and coordinate along the y direction. So let Rx be the distance of the particle along the x-axis and Ry be the distance of the particle along the y-axis. So we have Rx and Ry. Now, in order to find out the position vector R, we can use this formula. That is, position vector R is equal to Rx into I plus Ry into J. Now, if we have the position vector, we can find out the velocity vector. That is, you differentiate the position vector with respect to time. So that will be V. Right? So dr by dt will give you the velocity. So that will be equal to drx by dt into I plus dry by dt into j. Now what is drx by dt? That is Vx, velocity along the horizontal direction. And what is dry by dt? That is Vy, that is velocity along the y direction. So in order to find out the magnitude of the velocity, we can use this formula. V is equal to square root of Vx square plus Vy square. Similarly, you can find out the acceleration also. So how will you write acceleration in the vector form? We need to differentiate the position vector twice, right? So what is A? A is equal to d square r by dt square. So that will be equal to d square rx by dt square into I plus d square ry by dt square. Now what is ax here? Ax is d square rx by dt square, right? Similarly, ay will be d square ry by dt square. Now how will you find out the magnitude of the acceleration? So a will be equal to square root of ax square plus ay square. So if we have ax and if we have ay, you can find out the magnitude of the acceleration. So if a particle is moving along a curvilinear path, we will be finding out the position of velocity or acceleration in the vector form. Okay. So here we have represented the position vector, we have found out the velocity vector, and we have found out the acceleration vector also. So if we have the position vector, with the help of position vector, it is possible to find out the velocity vector and acceleration vector and also the magnitude of the velocity as well as acceleration. So you need to remember these formulas. Now the next coordinate system is the normal and tangential coordinate system. So here you can see a particle is moving along a curvilinear path. So when the particle reaches this point, this is the tangential line and this one will be the normal line. Okay, so if we have the tangential coordinate as well as the normal coordinate, it is possible to find out the velocity as well as acceleration. Okay, how will you find out the velocity? V is equal to square root of Vn square plus Vt square. What is Vn? Vn is the normal velocity and Vt is the tangential velocity. Velocity along the tangential direction and velocity along the normal direction. Similarly, you can find out the acceleration also. That is A is equal to square root of An square plus At square. Okay, so when the particle reaches this point, here the tangential path will be like this and the normal path will be like this, right? So if you are considering a particle somewhere here, then tangential will be tangential to this point and the normal line will be perpendicular to this tangential point. So it is possible to find out the velocity and acceleration of the particle when it is moving along this curved path. Okay. Now, the next one is the polar coordinates. So, here we will consider a fixed point or a fixed pole O and a fixed reference. It can be x-axis or it can be y-axis. Now, this shows the path of the particle and P is the particle. Okay. Now, how will you represent velocity with the help of polar coordinates? So, V can be written as Vr into I plus V theta into J. So, Vr is one component and the V theta is another component. Okay, that is with respect to the reference axis and this one is with respect to the fixed pole. Okay, what is Vr? Vr will be equal to dr by dt where r is the position of the particle. So, you differentiate the position of the particle with respect to time, that will give you the velocity. Okay. Now, similarly, you can find out d theta. So, that will be equal to r into d theta by dt. So, you need to remember this formula, that's all. Okay. Then, if we have Vr and V theta, you can find out the magnitude of the velocity using the formula Vr square plus V theta square. Similarly, you can represent acceleration also in the polar coordinate system. So, A will be equal to AR into I plus A theta into J. So, what is AR? AR will be equal to d square r by dt square in minus r into d theta by dt the whole square. You need to remember this one. Okay. Then, what is A theta? A theta will be 2 into dr by dt into d theta by dt plus r into d square theta by dt square. So, if we have AR and A theta, you can find out the magnitude of the acceleration also, that will be equal to AR square plus A theta square. So, you just need to by heart these formulas for solving the problem. Now, let us take the first problem. The motion of a particle is described by x position, right? X is equal to t square plus 8t minus 5 and y is equal to t cube plus 2t square plus 4t plus 4. We need to find out the initial velocity and initial acceleration of the particle. Also, we need to find out the velocity and acceleration of the particle at t is equal to 5 seconds. How will you approach this problem? So, here we can see that there are two coordinates, right? X coordinate is there as well as y coordinate is also there. It is given as a function of time. So, we have the position, right? Now, from position, we need to find out the velocity. If we know x, we can find out Vx, right? How will you find out Vx? Vx is equal to dx by dt. You differentiate the position with respect to time. So, Vx will be equal to dx by dt. So, that will be equal to 2t plus 8, right? Similarly, you can find out Vy also. What is Vy? dy by dt, right? So, 3t square plus 2 into 2, 4t plus 4. That is Vy. So, we got Vx and Vy, right? Now, how will you find out the initial velocity? Initial velocity means velocity when time t equal to 0. So, you can substitute t is equal to 0 in Vx and Vy. So, we will get Vx and Vy. If we have Vx and Vy, how will you find out the magnitude of the velocity? Square root of Vx square plus Vy square. Similarly, acceleration also can be calculated. How will you find out acceleration? You need to differentiate this position twice, or you need to differentiate velocity once, right? So, what is Ax? Ax will be equal to dvx by dt or d square x by dt square. You differentiate this equation twice, that's all. Okay, similarly, we can find out ay also. If we have ax and ay, we can find out the magnitude of the acceleration using square root of ax square plus av square. So, how will you find out the initial acceleration? By substituting t is equal to 0 in ax and at, right? Similarly, we can find out the velocity and acceleration at t is equal to 5 seconds. So, here you need to substitute the value of t as 5 in order to find out vx, vy and ax and ay. Okay. Okay. Now, the second one is the position is given with the help of a polar coordinate system, right? So, r is given here. R is equal to 5 plus 7 t square and theta is equal to 6 plus t square. We need to determine the magnitude of velocity and acceleration when t equal to 5 seconds. It's also a very simple question. So, how will you solve this one? See, r is given, right? R is equal to 5 plus 7 t square and theta is equal to 6 plus 3 t square. Now, how will you find out velocity? Velocity is Vr into I plus v theta into j. Now, what is Vr? Vr is equal to dr by dt. We need to differentiate the position with respect to time, right? Now, how will you find out v theta? V theta is equal to r into d theta by dt. So, we need d theta by dt also. Okay. So, what is dr by dt? So, dr by dt will be 2 into 7, that is 14t, right? What is d theta by dt? That is 2 into 3, 60. So, we got dr by dt as well as d theta by dt. So, you can find out Vr. What is Vr? Vr is equal to 14t and v theta is equal to, what is v theta? 5 plus 7t square r into d theta by dt, 60, right? Okay, now when t equal to 5 seconds, you substitute the value of t equal to 5 in this equation. So, you will get Vr is equal to 70 and v theta is equal to 5400. Now, how will you find out the acceleration? So, what is AR? AR is equal to d square r by dt square minus r into d theta by dt the whole square. So, we need d square r by dt square here. D theta by dt we have already found out, right? Similarly, here you require d square theta by dt square. So, first we will find out d square r by dt square. So, you differentiate this equation with respect to time again. So, it becomes 14. You differentiate d theta by dt with again. So, that will be equal to 6. Okay, now you can substitute these values in the equation. So, AR becomes, what is AR? AR is equal to 14 minus, what is R? R 5 plus 7t square, that is R into 6t the whole square. So, you can substitute the value of t here to find out AR. Similarly, you can find out A theta also. You write down this equation, substitute the values and find out the value of A theta. Once you get AR and A theta, you find out the acceleration with the help of this equation. So, A will be equal to, we will get this value. Okay. So, that's all for the day. Thank you.